Good morning, students. In this video, we are going to talk about principle of superposition for Coulomb's force. We are going to talk about the force, how we calculate the force when multiple charges are present. We have studied about Coulomb's law, which gives us the relationship for the force between the two charges. But how we have to calculate the force when multiple charges are present? Then we use the principle of superposition. Principle of superposition says that the force on charged particles due to number of point charges is the resultant of forces due to individual point charges, and also जो force जो act होती है that is independent of presence or absence of other charges. And in this case, in the electrostatic force, अगर हमारे पास दो charges present हैं, वो एक दूसरे पे कोई फोर्स एक्सर्ट कर रहे हैं, फर्स्ट एंड सेकंड चार्ज. अगर कोई थर्ड चार्ज प्रेजेंट है तो थर्ड अपनी फोर्स लगाएगा, लेकिन जो फर्स्ट और सेकंड की फोर्स एक्ट हो रही थी उसको वो इफेक्ट नहीं करेगा. तो वी से कि जो इलेक्ट्रोस्टैटिक फोर्स है दैट इज अ टू बॉडी इंटरेक्शन, दैट इज इलेक्ट्रिकल फोर्स बिटवीन टू पॉइंट चार्जेस is independent of presence or absence of other charges, and so the principle of superposition is valid. मतलब वो एक थर्ड चार्ज के प्रेजेंट होने से जो टू चार्जेस में फोर्स एक्ट हो रही है वो ऑल्टर नहीं होएगी, दैट विल रिमेन द सेम. एंड इफ नंबर ऑफ चार्जेस आर प्रेजेंट तो जो टोटल फोर्स है दैट विल बी द सम ऑफ ऑल द फोर्सेस, दैट विल बी द वेक्टर सम ऑफ ऑल द फोर्सेस. सपोज हियर we have considered one charge, this capital Q, जिस पे और अलग अलग चार्जेस प्रेजेंट हैं, से Q1, Q2, Q3, and we have to find the total force. तो total force क्या होएगी? Force due to first charge, force due to second charge, force due to third charge. Sometimes it is also written as like जो middle में charge है, अगर मैं इसको suppose मैंने इसको फोर्थ चार्ज ले लिया तो हम इसको ऐसे लिख सकते हैं, फोर्स ऑन फोर्थ ड्यू टू फर्स्ट, फोर्स ऑन फोर्थ ड्यू टू सेकंड, फोर्स ऑन फोर्थ चार्ज ड्यू टू थर्ड चार्ज, दिस वे. So this is a different notation to write. Otherwise the basic meaning is कि whenever the multiple charges are present then we are considering any charge, तो जो total force है that will be the sum of the forces due to the all other charges present there. Now we are going to solve numericals based on this concept of principle of superposition. Now this is an example of NCERT book. This is example number 1.6. Here we have given, consider three charges Q1, Q2, Q3 each equal to Q, means all the three charges are same at the vertices of an equilateral triangle of side L. What is the force on charge Q placed at centroid of the triangle? We have given that three charges each equal to Q are placed at the vertices of an equilateral triangle whose side is L given to us, and a charge capital Q is placed at the centroid of the triangle, and we have to find the total force on the charge capital Q. Now see, whenever we have to calculate the force, first of all we have to mark the directions in which the force acts. Now at O point charge Q is present. If I talk about this charge at B, it is positive charge. So this positive charge will repel the charge at O and force will be in this direction. अगर हम ये लाइन ज्वाइन करें, लाइन ज्वाइनिंग द टू चार्जेस, कूलम्स फोर्स हमने पढ़ा था किधर एक्ट होती है, एक्ट अलोंग द लाइन ज्वाइनिंग द टू चार्जेस. तो ये मैंने B और O पे प्रेजेंट चार्ज की लाइन को ज्वाइन किया, बिकॉज दोनों चार्जेस पॉजिटिव हैं तो जो B चार्ज है, B पे प्रेजेंट चार्ज है, वो O पे प्रेजेंट चार्ज को रिपेल करेगा, एंड दिस विल बी द फोर्स डायरेक्शन ऑफ द फोर्स. सिमिलरली जो C पे चार्ज प्रेजेंट है, अगर हम ये लाइन ज्वाइन करें वो O पे प्रेजेंट चार्ज को रिपेल करेगा, तो ड्यू टू रिपल्शन दिस विल बी द डायरेक्शन ऑफ फोर्स ऑन द चार्ज. नाउ दिस चार्ज एट A पे भी पॉजिटिव चार्ज है, अगेन दिस विल रिपेल द चार्ज एट O दिस वे. तो ये हमारे पास इस तरीके से तीन फोर्सेस एक्ट हो रही हैं एज शोन इन द डायग्राम। F1 फोर्स रिपल्शन की वजह से डाउनवर्ड, F2 फोर्स इस डायरेक्शन में एक्ट हो रही है, F3 फोर्स इस डायरेक्शन में एक्ट हो रही है। नाउ दिस पॉइंट O इज द सेंट्रॉइड. It means this point O is centroid. Centroid is the center of the triangle, means distance OA is equal to distance OB is equal to distance OC. Let it be equal to X. As O is the centroid, means all these three distances are equal. And if we have to find the force, magnitude of force, तो सभी forces का जो magnitude है F1 वो आपस में क्या होएगा, इक्वल F2 F3 एंड बाय यूजिंग कूलम्स लॉ दिस विल बी इक्वल टू 1/4 पाई एप्सिलॉन नॉट। हमारे पास होता है न्यूमरेटर में Q1 Q2, तो वन ऑफ द चार्ज इज Q, other is small q upon x square. तो we have used here Coulomb's law का expression use करके we got this कि force is given by 1/4 pi epsilon naught q by x square और तीनों forces का magnitude जो है that will be same. Now we have to find the resultant of all these three forces. Means अब ये हमारे पास all the three are vectors. अगर हम F2 और F3 वेक्टर का रिजल्टेंट फाइंड आउट कर लेते हैं तो जो रिजल्टेंट है या वी विल यूज हियर पैरेललोग्राम लॉ ऑफ वेक्टर एडिशन. तो रिजल्टेंट विल बी द डायगोनल पासिंग थ्रू द सेम पॉइंट, मीन्स रिजल्टेंट विल बी दिस वे. तो जो रिजल्टेंट अगर ये आ गया F2 F3 का, F1 डाउनवर्ड फोर्स है तो सेम लाइन के लॉन्ग आ गए तो सब्ट्रैक्शन से हम टोटल फोर्स जो है वो फाइंड आउट कर सकते हैं. नाउ ये सारी फोर्सेस डायग्राम में यहाँ पे शोन है F1 F2 F3. नाउ सी हियर वन थिंग मोर, दिस इज एन इक्विलेटरल ट्रायंगल, means all the three angles are of 60 degree. Now this line OB ये सेंट्रोइड की तरफ लाइन जा रही है, it means this angle, only this angle will be of 30 degree. ये जो एंगल है हमारे पास ये 30 डिग्री होएगा. सिमिलरली ये एंगल दिस विल ऑल्सो बी 30 डिग्री. नाउ इन दिस ट्रायंगल OBC ये एंगल 30 है, ये एंगल 30 है, तो दिस थर्ड एंगल it will be equal to 120 डिग्री. देन हमारे पास इक्विलेटरल ट्रायंगल में ये एंगल टोटल इज 60, उसका हाफ दिस इज 30, this is 30 and this angle is 120 degree. Now these are the two vertical opposite angles, means जो opposite angle है this one, this is also equal to 120 degree. Now if you remember we have studied in class +1 that if two vectors A and B they are of same magnitude and angle between them is 120, then the resultant is equal to either vector. We can prove it easily also. हमारे पास resultant क्या होता है, R equal to A square plus B square plus 2AB cos theta under the root. This is the resultant of the parallelogram law. Now if A is equal to B, let A be equal to X, any symbol you can use, और B को हमने equal to A ले लेते हैं, X हमने लेंथ लिया है तो don't get confused. ये हमारे पास A square, दूसरी फोर्स भी A square, दोनों फोर्सेस इक्वल 2A into A cos of 120 degree. Now what we will get here, these two when add up it becomes 2A square, this also becomes 2A square. Now cos 120 is minus half. You can find its value. We have studied in the rules for this also in the class +1. So these two will cancel out and we are left here minus A square, and 2A square minus A square means A square under root means A. So we have this property, you have to learn this property कि if two vectors are equal and the angle between them is 120 degree, then resultant is equal to one of the vector. Now all the forces are equal, so F2 F3 are also equal, So resultant is also equal to F. Now look at the diagram. One of the force F is acting upward and other force F is acting downward. So what will be the net force in this case? So net force will become 0. So we have used here the parallelogram law of vector addition, and using the law we came to this conclusion कि resultant is equal to either force, and since we are now left with two equal and opposite forces, so net force on the charge q, capital Q, present at the centroid will be 0. So we have used here principle of superposition, means we have added all the three forces present due to the three charges in the system. Now one more question is here. Here we have given, consider three charges Q, Q and minus Q placed at vertices of an equilateral triangle. What is the force on each charge? We have given कि three charges are present at the vertices of an equilateral triangle. I am drawing the diagram again. We have given a triangle. Let it be A, B and C. Three charges are present. It's Q, Q and minus Q. We have to find the force on each charge. Now, as I have told you earlier, first of all we have to mark the direction of force in the diagram. Now, the force on चार्ज ए, अगर हम ए की बात करें तो जो बी चार्ज है दैट विल रिपेल द चार्ज एट ए, और जो डायरेक्शन ऑफ फोर्स है दैट विल बी दिस वे. जो चार्ज एट बी है that will repel the charge at A because they are of same sign. So the force of repulsion will be this way. Now the charge at C, it is negative charge. So negative charge will attract the positive charge. So this will be the direction of force. इसको मैंने denote किया FB, force due to charge at B. इसको मैंने denote किया F at C, force at C. Now these are two forces and two adjacent sides of parallelogram. So what will be the resultant? Resultant will be the diagonal passing through the same point. Now look, the force due to B will be equal in magnitude force due to C. Force will be given by Coulomb's law, 1/4 by epsilon naught. The product of two charges Q into Q and distance between the two side of the triangle, let it be L. It will be L square. जब हम C की force लेंगे then same expression will be there, although the negative sign is there, but in Coulomb's law we have studied कि we have to put the magnitude only, we don't have to consider the sign because force is proportional to the product of magnitude of two charges. So take care of this, we don't put the sign of the charge in the Coulomb's law expression. So both the forces will be equal. Now notice one more thing, this angle is of 60 degree as the triangle is equilateral, means this remaining angle will be then 120 degree. Now again the same property will be used, as if both the forces are of same magnitude and angle between them is 120 degree. So जो resultant है हमारा that will be equal to either force. Resultant will be equal to either force. Same property is used and the total force will be given by 1/4 pi epsilon naught Q square by L square. So this is the total force, resultant of total force at A. चार्ज एट ए पे ये टोटल फोर्स हमारी एक्ट होएगी. सिमिलरली इफ वी टॉक अबाउट चार्ज बी, बी पे भी सिमिलर इफेक्ट आएगा. द चार्ज एट ए विल रिपेल द चार्ज एट बी, चार्ज एट सी विल अट्रैक्ट द चार्ज एट बी बिकॉज इट्स नेगेटिव साइन इज देयर. तो अट्रैक्शन की फोर्स इस तरफ हमारी एक्ट होएगी. अगेन एंगल बिटवीन देम इज 120 डिग्री और हमारा जो रिजल्ट है वो सेम आएगा. Now just see what about the charge at C. At point C, this is negative charge at C. The B charge Q positive it will attract it this way. Similarly, charge at A is also positive, it will also attract this way. Means these are the two forces acting on the charge minus Q placed at C. Whenever we have to find the force, first of all we will mark the directions. Only then vectors को हम solve कर सकते हैं. So these are the direction of forces. Now the angle between the two is 60 degree. So we can't use that property here and we have to solve it. So this is force due to A, this is force due to C. Again the magnitude will be the same. Magnitude of force, ये हम बात कर रहे हैं charge minus Q पे क्या इफेक्ट है उसको हम यहाँ पे स्टडी कर रहे हैं. तो force due to A, due to C, that will be 1 upon 4 pi epsilon naught. Whenever A ने कितनी force लगाई तो we will consider the two charges Q and minus Q. तो हमारे पास Q square upon L square. We don't use the negative sign in the numericals for the Coulomb's law. So what will be the resultant here in this case? Resultant will be first force square, second force square, 2A B cos angle between the two is 60 degree. So here this result will be somewhat different because angle in this case is 60 degree. Now let the force be, इसको मैंने F put कर लिया. Suppose F square plus F square 2F square cos 60. तो cos 60, here we will put the value of cos 60. Cos 60 की हमारे पास जो वैल्यू होती है that is half. Cos 60 is half. This 2 will cancel out. So we are left here 3F square. When we take it out from the under root, we get it under root 3F. So we will put here the value of F. F की वैल्यू हम पुट करेंगे, that is 1 upon 4 pi epsilon naught Q square by L square. So this is the total force on the charge minus Q which is placed at the point C of the equilateral triangle. So these are the numericals based on the principle of superposition of the charges. Thank you.